Here is the physical device I created for my project this semester. The main overview for this course was sensing, computation, and actuation. So as far as sensing, the main goal is to determine when the ball is present. So when we look down in here, we can see on the back side that there's an LED that is turned off, and right next to it is a photoresistor. On the opposing side of the tube, we can see that there's an LED that is currently in the on state, emitting light into the tube. What this allows us to do is when the ball is in place, it effectively blocks the photoresistor and reduces the light being transmitted. Additionally, we can see the motion sensor on the side of the tube to determine when the ball is present. When the system is activated, the servo motor will activate to move the door out of the way after the motors have spun up to allow the ball to be launched out of the tube. The Arduino is located right here, and what it is currently doing is the blinking built-in LED tells us that it is in the standby state. One of the key takeaways for this design is the fact that it is currently powered by a 12-volt battery source that you can see right here. This is used to power both of the DC motors as well as the Arduino, which is important considering the fact that this device is designed to be portable and used in an outdoors environment. Now I'm going to power on the device so that we can watch as the motors power the wheels to ramp up. Alright, so now we're going to look over the main code that overviews a lot of the basic functions of the ball launcher that I've designed. In void setup, we can see where I linked numerous devices such as the motors, the LED light, the input for the photoresistor, as well as the servo motor and the ultrasonic motion detector. The main part of the device is to determine whether or not the ball is present. So right here in this line we can see that if the photoresistor is less than the given value or the distance is greater than this value, the system will be activated. This is given an OR condition, which we can demonstrate as shown here. So in this case, what we had is the photoresistor value dropped, but the distance did not exceed, meaning that the system was activated by the photoresistor. In this situation, the system was activated by the distance sensor detecting the presence of the ball. The next stage checks to make sure that the number of launch cycles, which is an incremental counter, is less than the launch limit. If it's greater than, it will cause a temporary time delay, allowing for the motors to cooling and to prevent the dog from exhausting itself. If the launch cycles number is less than the launch cycle limit, it will continue onward through the first stage, which is going to activate the motor relays through an increasing duty cycle in order to ramp in the power to bring up to full speed, at which point the servo motor will activate and the door will open, allowing the ball to drop down the tube and shoot out. At this point, the motors will still remain on full power for 1 second. After this is completed, the launch cycle increment will increase by 1 count, and then the door will close. Here we can see that I used the processing code to simulate the actual device from a side profile to show the inner workings of the mechanism. When the ball is present above the door and the first indicator transitions to go, that means the motors are spinning up and the system is currently activated. When the second indicator transitions to open and the door moves out of the way of the ball and allows it to drop through the rotating wheels, this indicates that the ball is being launched from the system.